All right, so let's introduce some of the aspects of the formalism. So we're going to be looking for at least three different parts of the sentence that we'll be trying to express using our formalism. We're going to be looking at quantifiers, variables / names, predicates. And these we're introducing in addition to our familiar logical operators. So we'll still have our logical operators, but we'll have this additional formal apparatus that we'll study as we go forward. So let's begin by talking about predicates and variables. So a predicate, very straightforwardly, is just a property, an attribute, or a relation that something or some imagined thing can bear. Okay, so for example, the property of being read can be treated as a predicate, and the predicate we'll represent with an uppercase letter, like the letter R. And if I say, for example, that there is, let's say, for example, I don't know, Fido is red. I can represent Fido, as we'll see, as a name, or Fido is a name, but we can represent Fido as a lowercase letter f, and this then is a sentence, and the sentence says Fido is red. This is how we're going to read this. Now we're also going to use variables, and variables will take the place of names, so they'll stand for names. So as usual, we're using W, X, Y, and Z, the lowercase letters at the end of the alphabet, as our variables, but this time the variables take names. Okay, so here we've got a name and a predicate. So F here is the name, R is the predicate, and again we read this as Fido is red. Okay, so that's a perfectly fine sentence by itself. But we could have said, as we'll see, we'll end up introducing variables such that any name can go in and replace the variable for that name. So let's take a look at this. So here we've got a property like being read. But as we'll see, there are many different kinds of relations also that get captured by this. So by this formalism. So what do we mean by this? Well, a relation is also a property, but it's a property that things can bear sometimes to themselves, but also to other things. So for example, let's take here this predicate, L, and we'll say that that stands for love, or loves. And this is a two-place predicate. It's a predicate that takes two names or two variables and connects them by saying that there is this relation between them. So if it's L, J, M, then this is a sentence. Let's say J is John and M is Marie. This sentence says, John loves Marie. This is how we're going to read this thing. Okay. Now notice that the order is important. So if I had L, M, J, that would read Marie loves John. We could also have L, J, J, and that would read John loves John. Okay, all right. So now let's take one striking advance here is that we can represent multi-place predicates in a way that ordinary language will pretty quickly have trouble with. So this is a two-place predicate, and that's no problem. That kind of a relation is no problem. A three-place predicate is also something we can express pretty straightforwardly in English. So let's say, for example, here, the three-place predicate be is, let's say, between. We can read B, A, B, C here as saying A is between B and C, let's say. Or if it was P, let's say it was A, B, and C, where P is prefers. That's another three-place predicate, and here we'd say A prefers B to C. Notice the order here is critically important. So that would be so let's say it was like this. We'd have A prefers C to B, and that would express a different proposition. That would express a different state of affairs in the world. Okay, so that's the advance here. The thing is, as soon as we move to 4 and 5 place predicates, ordinary language begins to fail us. It becomes too hard to keep track of. We don't really have the kind of expressive capacity in ordinary language to handle 5 place predicates and above, 4 place predicates and above. So clearly we're doing something now. We're kind of extending our capacity to reason in an interesting way simply through this notational shift that Frege gives us. Okay. All right. So let's talk about love, and let's talk about how we're going to model these kinds of relations. So let's say, for example, we have a world with 4 objects, and these 4 objects have names, and we want to see how love obtains between these 4 objects. Okay, so let's draw the arrow of love. Okay, so in this representation then we see that D loves A, but A doesn't love D. A loves B, B loves C, and C loves D. So that's the arrow points in the direction that the love travels. So let's go ahead and make this a very happy world. And now, does everyone love everyone? Almost. Okay, so now we have arrows joining everyone to everyone. So here what we can say is that in this world, as it's represented here, everyone loves everyone. So everyone loves everyone. Okay. Let's draw another world, or maybe we could take the same world. Okay, and in this world, C loves everyone. So here we've got a case where someone loves everyone. Okay. Let's take another case. Someone is loved by everyone. Okay. So, as you can see, there's a variety of ways that the arrow of love can move around in this world, and there's a variety of ways that let's say we can represent the relationship, because there's a variety of ways that the relationship can be in a world like this. So let's take someone is loved by everyone. How about this? Someone is loved by someone. Okay, so clearly this world satisfies this proposition too, right? Okay, all right. So we can reason our way from here to here. Now let's think back to our original claim. Everyone loves everyone. Now that's certainly not the case here. So this isn't a representation of a world where everyone loves everyone. But let's forget that for a second and think back to our original world where everyone did love everyone. Let's even draw it in again. And notice they have to love themselves as well, right? Okay, so notice that this, everyone loves everyone, makes this proposition, someone is loved by everyone, satisfied. And that in turn satisfies this, that someone is loved by someone. Okay, so notice that we can begin to, with this graphical representation, begin to think about, okay, how we interpret these phrases, someone and everyone. And in a second, we'll begin to introduce the formal apparatus so that we can prove things about this stuff, okay? And if you look in the text, you'll see a more extensive discussion of that. All right, so let's take a look at the actual formal representation of the quantifiers. So here, what we'll have is this upside down A. The upside down A is the universal quantifier, and we'll show it with an x, a variable x or y. So it'll sometimes be y or z. And this says, this is read as for all x, or for all y, or for all z. And that's a sentence fragment, of course. We'll show how it's related to, or how it's embedded in a formula as we go forward. So this is the universal quantifier. And then the next one we'll look at is this one, this backwards E. And this reads for some x. Of course, we could have it y, z, w, etc. For some y, for some z, for some w. And this is what we call the existential quantifier. And this reads as for some x. Now, in English, when you hear some, you usually think, or we tend to think, more than one. But strictly speaking, what we mean here is at least one. So there is some x says, or should be read as, there is at least one x, and then we'll read the rest as, we'll sort of embed that as we go forward. So now, let's begin joining our quantifiers with our predicates, and this is what we get. So remember the R here is red, and this reads, again, going back here, for all x, Rx reads, everything is R. Or let's read it straight off the formalism. It says, for all x, Rx. So that's the way we're going to read this. We're going to read it as, for all x, Rx. And what it expresses is the proposition that everything is R, everything is red in this case. Let's look at the next one. There is some x, Rx. That's the way we're going to read it. When we look at these formulas, we'll say there's some x, Rx. And in English or in ordinary language, we'll say something like, there is at least one thing that is R, or some things are R. Okay? Right.